Hey guys, I'm having technical difficulty. My app isn't letting me post this for you. So we're going to do it this way.
Hello, everybody. Some students missed class on Friday, March 15th. So I made this little video to help catch you up. We started with a warm-up from the textbook on page 195, and it was question number 21 that we were doing. The instructions said, factor completely if possible. And it went on to say, be sure you can explain your reason why it's not possible if you choose to not factor something. So you can pause and take a crack at these questions A and B, and I'll show you my answer in just a moment. So if you were looking at question A, you're going to notice that 8 is not a perfect square and neither is negative 32. So that means I have to be able to factor out a greatest common factor before I do difference of squares. Otherwise, it looks like a difference of squares question. So I'm thinking 8d squared is made of 2 times 4 times, d squared. And 32e squared, I'm thinking if I divide 32 in half, I have 2 times 16, but 16 would be 2 times 8, but 8 would be 2 times 4. And then, of course, there's times the e squared, which I know is not in common. So it's interesting. And I could have broken the 4 down into 2 times 2, but because I see already it's in common, I didn't go that far. This isn't prime factoring. This is factoring to be useful to me in this process. I see a 4 in common. I see a 2 in common. So that means the greatest common factor is actually 8. And what would still be remaining in the brackets would be a d squared minus 32 divided by 8 is, 2 times 32 is 16. And 16 times 2 would be, or 2 times 32, 2 times 8 is 16. And 32 would take double of that. So that means I still have 4e squared. So now I see I do have perfect squares in my parentheses. So I can go ahead and set up to do difference of squares factoring. I would have to have a d in each bracket and a 2e in each bracket. One would be negative, one would be positive. If you paused and tried the second one, you might find that it's a little weird. We've never factored anything with a fraction in it before. But I'm going to ask you this. Is 25 a perfect square? Yes. Is m squared a perfect square? Yes. Is 1 a perfect square? Yes. Is 4 a perfect square? Yes. Is n squared perfect square? Yes. So you would take the square root of each of those terms. You can also take the square root of each of these terms. So prime factoring this, we're going to start with difference of squares, 2 brackets. One will have minus, one will have plus. 25, when I take a square root, is 5. M squared square root becomes 5m. 1, when I take a square root, is 1. 4, when I take a square root, is 2. And n squared would leave just a single n. Check it out. We've never used fractions before, but you can do not prime factoring, excuse me. It's early on a Saturday morning. My brain's not totally sharp yet. But you can do factoring of fractions if they are perfect squares. So we had a couple more questions in our warm-up, and I want to make sure you see them because Weird things sometimes happen, just like those fractions. You would have not ever seen them if we didn't do them together. Try these ones, factor if possible. And if you don't factor them, make sure you have a solid reason why you couldn't. Hopefully you pressed pause and did the work, and now you're ready to see some answers. So when I look at C, I think it looks like a difference of squares question because it's a binomial, but 18 is not a perfect square. So I'm thinking right away, 18 is made of 2 times 9. And then I would have times x squared times y squared, xy. Look at me, that's how tired I am. Craziness. Times y squared. And I'm thinking the other term, 50, could be 2 times 25 times y. So I would be factoring out the greatest common factor. 2 goes in front. Now, some people would open their brackets right now and start filling in what they need to, but do not forget y squared is the same as 2 of the y's that we're hiding in that y to the exponent 4. So they're part of the greatest common factor. So now we can go do 9x squared is still left there, minus 25, and y squared is still there. Now that looks like a perfect square for each term in the brackets. So the second step is to factor using difference of squares. 3x in both brackets. One gets minus, one gets plus. 5y. So that has been factored completely. Did you factor D and E? If not, press pause, take a crack at them, and come back for what I say after. All right, so 25 is a perfect square root, or perfect square number. We can take a square root. S squared also, 49 also, t squared. Yep, they're all numbers that can be easily taken a square root, but dun dun dun, this is not a minus. This makes it not a difference of squares factoring, because without a minus, we don't have a difference. And there's no minus on the first term, so we're not able to rearrange it and make a minus in the middle. So we cannot factor this right now with the strategies that we've been given. For 10a squared minus 7b squared, we can try to factor it, but the only factors of this prime number are 1 times 7. And when I break up my 10, I have 5 times 2. There is no common factor. So I can't pull out a greatest common factor in front of my brackets and then see a perfect square that I can take square root of. So this is also not difference of squares, because we don't see perfect squares or hidden perfect squares if we were to factor out GCF first. So we don't have a way of factoring this in our bag of tricks just yet. So that was a little bit of a review. Let's take a look at factoring trinomials. Oh, I had one more question, silly me. For this one, you can definitely factor it even though it's a fraction. Each element here can be taken as square root. You would have x over 4. You would have y over 7 plus x over 4 minus y over 7. So you can factor if they're perfect squares and there's a minus in the middle. You can factor using the same strategy, even when it's fraction. Okay, trinomials are next. We worked on the photocopies that are on D2L from 111 to 116. 116 is a homework assignment to submit. I really suggest that you do the work and get the practice. Otherwise, you will find the unit test is extremely difficult. So even if you are jumping to 116 and doing that and not all of the practice, that would be better than doing no practice. On page 111, there's examples, and then we get into some try these questions. I went over with the class questions A and C after people tried them, just to make sure that we've got the flow of how to work this new kind of factoring. So remember that we were factoring using product sum method. For A, by the way, press pause and work them out if you want, and then come back for the answers. For A, we are looking for numbers that multiply to make 14. So I immediately think, oh, 2 times 7 makes 14. But then they need to give me a total of -9. So this is where we're looking for the sum. This 14 is our product. That's why we're looking for factors. So if I pick 2 times 7, there is no way that they're going to give me a -9. So that means I have to figure out where to put some negatives on my 2 and my 7. So if I do -2 times 7, well, that ends up with a -14, so it doesn't give me the product I need anymore. If I do 7 with the negative times 2, that still gives me -14. Anytime you have an odd number of negatives in your multiplication, the negative will win and the whole term of your answer becomes a negative answer. So that means I could try -7 times -2, because a negative times a negative flips to positive. So that would still preserve my +14. And if I do -7 plus give it an extra -2, that gets me the sum of -9. So that means I can put A in one bracket, A in the other bracket, just like we used to do with difference of squares. And now I'm going to grab these numbers, -7 and -2, and I'm going to write them in my bracket, -7, -2. And I am finished factoring that simple trinomial. We call it a simple trinomial because there's no number in front of that A squared. There's no coefficient. When we get to the next question, it doesn't look the same. Our x squared is at the end. Now, what you need to remember is the first week of school, we talked about how mathematicians always want the terms to be organized. And we said they want them alphabetically. We also said they want them organized with the greatest exponent presented first. And this question C does not have the greatest exponent presented first. So we can reorganize it. We'll take that positive x squared and we'll put it at the front. Then the term with the x's, the -5x. And the very last thing will be that whole number of -24. Now it looks like something we can actually do. So it's a simple trinomial. Set up your 2 brackets. Put an x in each bracket because we need them to multiply with each other in order to make x squared. Now we're trying to figure out what makes a product, what multiplies to make -24. So you might be thinking 12 times 2, but when we add those together, they're not going to make a -5. Maybe you're thinking 6 times 4. If we add those together, we're going to get a 10. And we also need to worry about our negatives. They're not in that. What if we do 8 times 3? Oh, this has potential. 8 minus 3 would give me 5. Or negative 8 plus 3 would give me negative 5. And one single negative in my multiplication would make the negative I need for negative 24. So I'm going to make my answer negative 8, positive 3 in the bracket. And of course, when you're finished, you can check it by multiplying each of those terms. So that was factoring simple trinomials, and there's lots of practice in your packet. But on page 116, you're going to bump into some that look a little different. On page 116, you're going to bump into numbers in front of the x squared. And all you need to do is factor out a GCF. And hot tip, the GCF is going to always match the number that you have in front of the x squared. So we're going to divide every term by that coefficient. Divide by 3, divide by 3, divide by 3. And what you're going to end up with is your 3 goes in front of the brackets because it's your, your 3 goes in front of the brackets because it's your greatest common factor. And then you would still have x squared in the first term. You're still going to have minus, but now it's 10x in the middle. And when you type 72 divided by 3 in your calculator, you're going to find 24. Now, what you're looking at is a simple trinomial in those brackets. So bring your greatest common factor with you. Set up 2 brackets for factoring the remainder. You know you have to have x in the beginning of each of them. Now, 2 numbers that would multiply to make a positive 24, but add to give a negative 10. Well, the only way I can get a negative is if there's negatives in my factors. And I know I can't put a single negative. It has to both be negative because I need that positive 24. So I'm thinking negative, let me think. Negative 4 times negative 6 can make positive 24. And it can also add together to make a negative 10. So I'm going to put that minus 4 minus 6. And I have factored that trinomial in more than one step. I had to factor out a GCF first. One more example. Now we have a negative 5 in front. So I'm going to factor out greatest common factor by dividing every term by a negative 5. So that means I have negative 5 in front of brackets. I now have a y squared. Negative 20 divided by negative 5 leaves me with a positive 4y. Negative 60 divided by positive 60 divided by negative 5. I know 5 times 6 would be 30. So double that would be a 60. So 12. And it's got to be negative because in that division, there's an odd number of negatives, and so negative wins. What did I say? Negative 12, I think. Then you're going to do factoring just like you do for a simple trinomial. Y in each bracket. 2 numbers that multiply to make negative 12. Add to do 4y. I am thinking 6 times 2. I need one of them to have a negative to create that product of negative 12. but I need a positive for what I'm adding. So I need the stronger number or the larger number to be the positive. So that 6 is positive, that 2 is negative. I always think of it as a tug of war, which number would win, the positive side or negative side. So I have +6 and I have -2. So your unit test is Wednesday. Be sure to get lots of practice and pass in homework so you get feedback. So that way, if you're doing something wrong, you know before you get to the test, and I can give you a little bit of extra help. Have a good weekend, guys.